Hello students, welcome to the new topic that is SHM. Now this chapter is very important in the perspective of G mains and G advanced specifically because this chapter can include many of your G advanced chapters. You can mix SHM with any given chapter. That's why this becomes very important. Now this session particularly will be an introductory session, right? As I have less time for this, but you can any day personally message me, DM me, right? You can contact me Urban Pro and I can help you learn this topic in detail so you can solve each and every question, right? Now, let's start. Now, what is SHM? SHM is simple harmonic motion, right? What is simple harmonic motion? It is the simplest form of oscillatory motion. Okay. Now, SHM are of two types. One is linear SHM, one is angular SHM. SHM are of two types. Linear SHM, right? Another one is angular SHM. What is linear SHM? When a particle moves to and fro about a fixed point called equilibrium point or position, right? Along a straight line, then its motion is simple harmonic motion, right? Now, example, a mass is connected to a spring. Very simple example. Block of mass M, a spring, and it's going to and fro motion like this, right? Like this. This is example of linear SHM. Now, what about angular SHM? So let me shift it below. Yeah. Now, when a system oscillates angularly with respect to a fixed axis, here the position won't be fixed, but the axis will be fixed. Then its motion is called as angular simple harmonic motion. So when a system oscillates angularly, when a system oscillates angularly with respect to a fixed axis, right? Then its motion is called angular simple harmonic motion. Example, motion of a bob of a simple pendulum, right? So if you take a simple pendulum, so it can go this direction, can go in this direction. So to and fro angularly with respect to fixed axis, right? This is angular SHM. Now, some necessary conditions. To execute SHM, we'll discuss 2 points, one for linear, one for angular. A necessary condition to execute SHM first in linear SHM. The restoring force or acceleration acting on the particle should always be proportional to the displacement of the particle. Right? And directed towards the equilibrium position, the force. Very important. Right? What means force should be proportional to minus x, or acceleration proportional to minus x. Why minus x? Because of this particular point directed towards the equilibrium position. So if my equilibrium position is this, right, and my block has this movement. So if the movement is in the this direction, so the spring will pull him or the block towards the equilibrium position. The force would be acting in the opposite side of the motion. So if the motion is x, the force will be acting towards minus x, right? Now, if the block is in this side, that is, the block does a negative motion, minus x, then the force would be acting on the other side because it will compress the string and the string will try to push the block. If it tries to push the block, the force will be in this direction and the block is in this direction. Then also it is minus x, right? The force will be positive in the distance is negative. So there will be always a negative sign between these, right? You got it? Negatives, let me also note it down. Negative sign shows the direction of force. Force or acceleration, anything, right? You got it? And acceleration is always towards the equilibrium position, and x is the displacement of particle from equilibrium position. A is the acceleration towards equilibrium position, right? X displacement particle from equilibrium position, right? I hope you got it. Let's talk about angular resistance. So for angular resistance, the restoring torque of angular acceleration acting on the particle will always be proportional The angular displacement of the particle and directed towards the equilibrium position. Exact same thing, right? The torque is proportional to minus theta, the same explanation, or the angular acceleration is also proportional to minus theta, right? Now, as I have less time constraint, I'll just give you a brief intro about the energies of simple harmonic motion, right? If you want to know the depth topic, you can anyway, personally message me in any platform, right? In Urban Pro, you can text me also. All right. Now, energy of particles in SHM. I'll just introduce you. Just a sec. I need to. Energy of particles in SHM, right? First, potential energy. We all know the formula, right? Formula is F equals to minus du by dx. Force is minus differential of potential energy with respect to the dx, the distance, right? Which means if we integrate du, we'll get minus integration of f dx, right? Now for SHM, we all know f equals to minus kx, right? So solving it, du is minus integration of minus kx dx, right? It's equal to kx dx, which is equal to half kx squared, right? So u equals to half kx squared plus c, right? Now at x equals to 0, u equals to u naught, the initial potential energy. Therefore, c equals to u naught, right? So u can be written as half kx squared plus u naught, right? Where the potential energy at equilibrium position, right, is equals to u naught, where u naught is 0 when, when u naught is 0, then u equals to half kx squared, right? Very easy. Now, if I talk about kinetic energy, right? Now, these energies are in terms of displacements, in terms of displacement. There can be another energy in terms of time, which I'll cover in the other classes in which maybe if you personally text me because I have less time here. Second is kinetic energy. This is also in terms of displacement. Yeah, right. Now, so displacement. If the mass of the particle undergoing a system is m with velocity v, yeah, right? Then kinetic energy at any instant is equal to half mv square, right? A is equals to half mv square is equals to half omega square a square minus x square equals to half k a square minus x square. Now, what does this mean, right? So, I wish I could explain you properly, right? What is a, what is x? But here, x is the amplitude. It says that if the graph is this, Yeah. So A is the amplitude, right? And X is the distance moved till that point. So if X is at mean position, X is 0. If it is an extreme position, then X would be A, right? And in SHM, the kinetic energy is an inverted parabola function of displacement, right? If I say this is X, this is minus A, this plus A, it goes like this. Well, this is the highest position, right? KE max. What will be KE max when X equals to 0? Half KA square, right? What is K? K is M omega square. So it is half M omega square A square. These are the basic formulas, right? Uh, which is very easy to derive. If we also take the time in consideration and we go ahead in this topic, we can derive this formula easily. So this is the formula of kinetic energy of SHM. And this was SHM and basic concepts of, let me draw the graph of potential energy also for you guys. Potential energy, the graph is in normal parabola. In kinetic, it is inverted. In potential, it is normal parabola, where this will be the U max, which is half K square, right? This is minus A, this is right? Minus it plus are the total maximum and minimum amplitude by which your body can move, right? So that was it, guys. Thank you so much for listening. This was Utkal, right? Thank you so much. If you want to know more depth knowledge in SSM, please contact me, right? Via Admin Pro. Thank you so much.